Hello. Hello, hello, hello. Okay. So it looks like we are able to stream fine today. And okay. So we'll continue with the question that we were doing yesterday. Okay. That is this question. Flowers. Okay. So last time we were trying to figure out how to solve that problem. And what I suggested was that we can do a simple like a knapsack type thing, but with a simple condition that will have a HMAX type HMX check, H height check. Okay, so that it is in a sorted order. But the thing is, if we do it like this, then we know that H can go from 1 up to n, and also that n itself can go to 10 to the e 1e5. So it will be like 1e10, and that is not that is not efficient, and so we need to find a new method, new way to do it. Okay, so suppose we are at for this example, let's take this example. Okay, so we have this 3 1 4 2 with their respective beauty points, and let's say that dpi represents the maximum possible sum of beauties till what? Maximum possible sum of beauties till I. Okay, so how do we calculate this? So we have, let's say we have different index, right, starting from 0 1 2 all the way up to I, and then up to n. Okay, we have all this. So we are at I right now, and this guy has a height hi and a beauty of ai. So to include hi in the remaining flowers, okay, so we have two groups, right? We have two groups. One is flowers picked, and the other is remaining flowers. Okay, so if we pick out this flower, then there is no need to check, then we don't need to do anything. The main thing is when this ith flower is in this group, that is remaining flowers group. So if it is in the remaining flowers group, then what is the maximum possible sum? We know that this guy can only contribute to the sequence or subsequence that is coming from the left, where the last element of that subsequence has h that is strictly less than hi. Okay, because we need an ascending order. Okay, monotonically increasing from left to right. Okay, so we need that, and we need to find the highest such highest beauty flower, okay, in under such conditions. So what we need to do is we need to find j, such that hi is less than hj is less than hi, okay, uh, and of course j will add this value. We need to find this the maximum j, maximum value, such that hj is less than hi and also the sum is maximum, and will then add this to our dp. Okay, so this is the simple flow. If this is not this is not going to work, then this will work. But the thing is, we need to find the maximum j for each I. Okay, how can we do that? Can we do some binary search type of thing? Is it possible? Let's see how my stream is working. Okay, it is working. So we need to find j such that this is hj is less than hi, but the beauty sum is higher. So what we can do is we can try a priority queue, maybe, that will contain the beauty values, okay, or maybe we cannot do n square anyway, so there is no scope of iterating from 0 to I for finding that value, finding that flower subsequence. So okay, so j is basically a subsequence ending at j, right? So maximum possible, the dpj will be maximum possible sum of beauties till j. So we are just continuing with ith flower, we are continuing that subsequence with ith flower, okay. Yeah, and this is not plus equal to, this will be equal to the beauty of the ith flower plus dp. I hope. Okay, so yeah, this is our transition. This is our state. And our base case will be like base case. What do you think the base case can be? dp0 is 0 only. Also, I think dp1 will be a1 only. Okay, and answer will be in dpn. How do we get the maximum value? But how do we get the maximum value now? Okay, that is the main you can say crux of this, or to solve this problem. we can have a priority queue, but uh, we can have n, we can have n, right? Okay, so I think priority queue should work. So what I'm thinking is we'll have a custom function for priority queue. We have a priority queue. Okay, it will have a pair of int. Okay, and in one will store need to check for the height also now, so that might not work. Updating in priority queue is like it's not efficient. For example, if we have for example we are at this 4, okay, and we have to find a flower which has height of less than 4. So these, both of these can be like correct, or both of these are feasible, but the thing is that we need to sort them based on their this value, beauty value, but also we need to check for all the values that is less than 4. So basically we'll be looking for all the values that is less than h, right? And yeah, that is not efficient. Need to find something else. A different way of getting the jth, getting the dpj. What happened? That was very random. What happened? What happened? Bro, my notes. All my notes. What? Okay. Okay. Oh, we have still have it. I thought that was some. I thought they deleted my account or something from Miro. Okay, so we have the notes still here. Still have the notes here. But I'm not sure how to get the DPJ. So we'll look for it. Atcoder DPQ flowers. Okay. Okay. Nothing. Forum. Okay. What the fuck? That's a segment tree. I actually forgot like the how the segment tree works. It's been a long time. Yeah, every solution is segment tree. This is a bitwise. Let's see at Nachiket. Just a second. So they are using segment tree for calculating this part. Okay, so at first we were trying to store dp with position, right, of array position, but now uh, since height is distinct, right, so we can try with heights as dp subscript. For example, instead of dpi being the sequence ending at ith index, we can have the like answer when height when sequence height ends at I. So doing that will help us in what? So for example, if we are trying to calculate dpi, okay, so of course we'll need ai, plus also we will need the maximum from all elements till I minus 1, right, where I what does I actually, I is basically the height. Okay, so for all the heights that is less than I will be considered for the answer that is already processed. Okay, so this thing can be done using segment tree. And the thing is, I've forgotten how, I mean, it's been a long time, so I remember some stuff, but I'm not sure if I can like explain them to you. Like that guy I was explaining, I understood some part of it, like most of the part. Okay, I understood most of the part, and I probably can try run it if I try. Thing is, the first step in any segmented problem is building it, right? And how do you build it? You basically want n nodes at the last layer, whatever. Like for example, if we are building for height, right? So if we have like n height, and for in this example we have four distinct height, right? So let me just do it like this. So we have to have 1, 2, 3, 4. Okay, and out of these I will make a tree, a binary tree. Okay, and something here also. So what this will show me is that for different heights, okay, for different heights I am storing the values. Okay, so for 1 height, for 2 height, for 3 height, and for 4 height. And when we are traversing it, like in the process of building the tree, we start from here, right, from 1 to n. Okay, then we break it till we get both of these as equal, and at that point we'll update the value, and initially all will be 0. Okay, and when we are returning from it, we'll update the entire tree. So that is how the building works. Okay, and similarly all of them will be processed, and at the end I think the maximum of all will be at the top. So basically 40 will be at the top. We'll have 40 from here, we'll have 30, or yes, we have 10 here, we have 20 here, we have 30 here, and so this will be 40, this will be 20, and maximum will be 40. So we'll have a segmentary build like this, and when we try to query it, suppose we are now at this location. Okay, we are now at this location 310. Okay, so of course we'll try to update it. First we'll need to find it. We need to find the when we are at here dp3, will be like I'm going to add a1 plus I will need to find the maximum till 0 to 2. Okay, and that 0 to 2 we can find from here, and this will be returned from it. But the thing is, they have not been processed yet, so they will be 0 in the first, I think. Yeah, they should be 0. So all of them will be 0 initially. So this is basically what this is a max segmentary only. Okay, but if we do it like in a sequence, then it will solve the entire problem and give the answer here. Okay, so we can try run it. So for dp3, all of it will be 0. Okay, and let me make a new tree for this. We are here, and then we go from here to here, then here, then here, then here, then here, and then here. So everything is 0 at first. Okay, dp3, where is dp3? dp1, dp2, dp3. Here is dp3. So it is 0, so we'll add what? We won't add it, we will first have like this, and then we'll query it from 0 to 2 what is the maximum. And since we know that there is the maximum is 0 only, so it will be like 0. So whatever value that we get, we will then update it to our tree. So it will be 10, this will also be 10, this will also be 10. Okay, now for the next part, for dp4, similarly we'll check what we can can we find anything from 0 to 3, and this time yes we can. And what we can do is we can find dp4 will be nothing but 20 plus 10, where 10 coming from dp3, so it will be 30. So this will be 30 here. Okay, maximum of which will be maximum of which will be 30, and again this will be 30. I guess I fucked up. This is 3142, not 3412. 3142. Okay, but you get what I'm like. How I'm solving. You get right. You get how I'm solving it. So in this case, this will not be solved because one is the the least height, right? So it will be 20 only, plus 0. So one will be 20, max 20, and here max will be 20. Now we have dp4 to consider, and dp4 will be what? We are adding 30 plus whatever maximum I can get between 1 to 3. 1, 2, 3. So 1, 2, 3, what is the maximum that we can get? I think the maximum will be between these two, and it is 20 only. So it is 20. But yes, so it is 20 only, so it will be 50. So dp4 is now 50, and this will be 50. This will be 50. Now we are at dp2. So dp2 will be adding 40 plus what is the maximum that we can get between 1 to 1, and of course we can get 20, so it will be 20, so it will be 60, and we will get 60 here, and we will get 60 here, and we'll get 60 here, and the answer will be 60. So like this. So I think we understand enough to implement it now, and this is the yesterday's file that we haven't touched. Let's write a class. Let's just say st. Okay, we have a vector. Do we call a segment tree? Okay, we have a segment tree. What else do we need? I don't think we need anything. We'll just build it. What do we need here? We have the height. We have the height in. We have the height in one indexing, right? We have the height in one indexing. That doesn't matter anyway. So we'll have a low, we'll have a high, and we'll have index, and we'll have an array, so from which we'll fill this thing. So if low is double equal to high, in that case what? If low is double equal to high, in that case we can have segment of index is equal to a low. Okay, and what else? Just need to return from it, right? So we will return and we'll calculate a mid value, which is nothing but low plus high by 2. We'll keep it to break the segment tree, and we'll build so low to mid with index will be 2 into index plus 1, and A will again build from mid plus 1 to high, and x will be 2 into idx plus 2. Okay, wait a second. Okay, mic is on. Okay. So where was I? It will be 2 into index plus 2, again A. Okay, and while turning we'll update the segment tree. Okay, so it will be seg index will be maximum of segment of 2 into idx plus 1 and segment of 2 into idx plus 2. And before building we need to initialize the segment tree. So SG tree will take n in the input, that is sufficient. Okay, build is done. We need to update it. Okay, we need to update it. Before that we need to query it. Okay, similarly the build will have a low, will have a high, will have an index, and for querying, right, what else? I think it is enough. There are two more parameters in query. I think it is the start and end, maybe. Like, how do we decide whether the segment in consideration lies entirely inside that range, or it is like partially overlapping, or it is not even in that range? We need to decide that somehow. I'm forgetting max set tree. I have that segment tree, I think. Okay, so we have okay, we have segment tree, and looks like for querying we need 1 2 3 4 9x. So this is the desired range, this is the entire range, and if the desired range lies entirely inside the entire range so we'll just return like this, complete overlap. Okay, so low high is the desired range and LR is the entire range, I think. Okay, and no overlap means L is R is less than low. Okay, like this or like this. Okay, we'll just copy it. No need to thinking about stuff that you can just copy. I mean, that was kind of wrong. So anyway, no need of thinking about stuff that you've already done and you understand, but you don't want to write. Yes, and we'll return max. Low plus high minus by 2, and also okay, let me change the structure itself. We'll have idx, we have low, okay, this, okay, we have high, we have lnr. Okay, cool. And then update. Where is my secretary device? Update. Okay, so for build and update, the first thing is similar. So if again we don't need okay, we need I and value, that is why do you need I? What is the use of I here? There is no use actually. I has no use. Okay, no, it has sense. I will be used to check the index. Okay, since we are going deep into the tree, we cannot use the segment tree syntax, but rather we need to check for the index from that array or whatever. Okay, so we'll need index, we'll need low, we'll need high, we'll need I, we'll need val, and in case low is equal to this, we'll do this and we'll calculate mid, which is low plus high by 2, and if I is less than equal to mid, that means we need to go to left side, so we'll update and go to left side, idx plus 1 and low comma mid comma I comma val, else we'll go to the right side, which is 2 into idx plus 2 comma mid plus 1 comma I comma val. And while returning we'll do this. segment index is equal to maximum of segment of 2 into index plus 1 comma 2 into index plus 2. Okay, so this is done, this is done, this is done. We need input. Copy paste. We'll take n, sorry, we already have n, so take n. We need height and we need beauty. We'll take input in both. Here also we'll make a segment tree. Okay, yes, st of size n, and we'll build it. We'll have a dp also. Not VLL, it can be this only. We can have 1, 2, 3, 4, 5, 25. Okay, so we'll build the tree. Okay, sorry. 0n Okay, segment tree is built, and then what we need to have this. Base case. I think I can do it in runtime or maybe in loop only. So we'll go from We'll go from where? We'll go from this thing is 0 only, so we'll go from 1. And what we'll do is we'll check, not check, I will do dpa is equal to dpa I minus 1 plus st dot query zero zero We'll need to do segmentary questions as well. I guess what I'm trying to find the maximum or minimum query or sum, like this one. We have the LNR, we have low and high. So when we are querying, this is our desired thing. Okay. If okay, no, low and high is basically what what my range, total range is, right? And LR is my desired range. So it will be N and this will be LNR, right? So it will be from 0 to what? H I minus 1 minus 1. and then we'll update it. Zero, zero, n. I is what? I is I. And value DPI. Think this should work, and at the end we'll give error. Okay. Forgot. Update was not declared. Of course not declared. Okay, 0. How? Some issues. What issues? we are doing one indexing. Okay, one thing that I need to do is this thing, cfi1 ncnhi copy paste and bi. Okay, okay, we are returning this, right? Return 0 50. There is issue somewhere. Okay, this is not correct now. This should be like this. Okay, still not right. If we are doing zero indexing, okay, so if we are doing zero indexing, why it is like this? Should be this. If we are doing zero indexing like this guy did, then now we'll do from here to here. I'll do it here. We'll do it here. We'll build till n-1. dp will be till n. Okay. ओके सो ये डी आई नहीं है, डी ऑफ एच आई है, क्योंकि कोर्स भाई Okay, so we have all the height, right? So, and the segment tree itself is a zero index segment tree. So we, for updating the h height value, we are doing hi minus 1 and providing that with the dp value. Okay. Damn. This should work. Let me test. Okay. May not fit into 32-bit integer. What is the issue here? Why am I not getting the correct answer? Okay, I knew it. Not updating it. Or instead of this, can we just do this? Or not? Sorry. What was the issue with 4 out of them? Sometimes, can't even say. Okay, so. I think we are done, and it took like 2 hours to solve this problem, even though I was looking at the solution. Okay. Wrong answer. TLE, MLE, anything. Okay, so I think that was it. And even though we looked at the solution, I still took 2 hours. I need to work on DP plus segment tree plus graph. Okay, so Christmas, New Year, holiday, I'll work on it. Also, this is to announce that I most probably will not be able to stream tomorrow, the day after, and like for this, the rest of the days for this month, I think. Or if I stream, it will be silent stream. I will not be able to speak. Yeah, so there is that. And other than that, if I have any announcement like regarding the project that I am working, like or I'll be working on, like for building portfolio and stuff, I'll post it and like try to schedule a different stream for it. Yeah, that we can do. So for the DP, most of the stuff I have remembered, but like NCM and of course when different concepts are involved, like for example you have that binary search, segment tree, graph tree with DP. So in that problem, in those type of problems, I have issues like where DP doesn't bottleneck me, the other like topic bottlenecks. So yeah. Okay, so that was it for today's stream, and we'll meet this year or next year. We'll see. Till then, I hope that you have a very happy, a very I wish you Merry Christmas, and I hope that you have a very healthy and fruitful start to this new year that is coming. And yeah, and an early happy new year from my side. And bye.